Hi friends, welcome to my channel. Please like the video and subscribe to my channel, if you like the video. In this video, we will try to study about properties of fluid, from the subject, fluid mechanics. As we know, we have three different states of matter: solid state, liquid state, and gaseous state. Fluid is a common term used for both liquids and gases. That is, a property of fluid means that the property is valid for both liquids and gases. Fluid mechanics is the study of behavior of fluids in both static and dynamic conditions. Fluid statics deals with the study of fluid in static condition. That is, there is no motion of fluid. Fluid dynamics deals with the study of fluid in motion. This topic is further subdivided into fluid kinetics and fluid kinematics. Fluid kinetics is the study of motion of fluid by considering cause of motion. Fluid kinematics is the study of motion of fluid without considering cause of motion. Now, we will study the properties of fluid in static condition. Before that, we are remembering that weight is equals to mass times acceleration due to gravity. Weight is denoted with capital W, and is measured in newtons. Mass is denoted with small m, and is measured in kilograms. Acceleration due to gravity is denoted with small g, and is measured in meters per second square. Property 1. Density of a fluid. Density is also called mass density. It is denoted with ρ. Density of a fluid is defined as mass of the fluid per unit volume. ρ is equals to mass, m, by volume, v. Volume, v, is the product of length, breadth, and depth. In general terms, take 1 meter length, 1 meter width and 1 meter depth of a container and fill it full with any fluid, then measure mass of the fluid in kilograms. This value of mass of the fluid gives the density of that particular fluid. Units of density are kilograms per meter cube. Density of water is 1000 kilograms per meter cube, and density of mercury is 13,600 kilograms per meter cube. Property 2. Unit weight. Unit weight is also called as specific weight or weight density. Unit weight is denoted with gamma. Unit weight is defined as the weight of the fluid per unit volume. Gamma is equals to weight, W, by volume, V. In general terms, take 1 meter length, 1 meter width and 1 meter depth of a container and fill it full with any fluid, then measure weight of the fluid in newtons. This value of weight of the fluid gives the unit weight of that particular fluid. Unit weight is measured in newtons per meter cube. We know weight is equals to mass into acceleration due to gravity. Substituting this in the unit weight formula, we get unit weight, gamma, is equals to mass times acceleration due to gravity, divided by volume. Which further gives unit weight, gamma, equals to density, ρ times acceleration due to gravity, g. Unit weight of water is 9,810 newtons per meter cube, and unit weight of mercury is 13.6 times 9,810 newtons per meter cube. Property 3. Specific gravity. Specific gravity is denoted with capital G. Specific gravity of considered fluid is defined as the ratio of density of considered fluid to density of standard fluid. Or, it can be also defined as unit weight of considered fluid to unit weight of standard fluid. Standard fluid is always taken as water. Specific gravity has no units. Property 4. Specific volume. Specific volume is the reciprocal of mass density. It is defined as volume of fluid covered by unit mass of fluid. Units of specific volume are meter cube per kilogram of fluid. Property 5. Viscosity. When a fluid is allowed to flow on a surface, it will flow in the form of layers. The motion of top layer of fluid is restricted by its bottom layer. This property of fluid offering resistance against motion of fluid is called viscosity. This figure here shows flowing fluid in layers. Fluid is flowing towards right, but resistance is offered towards left, further developing a condition of shear in fluid molecules. Consider last fluid molecules 1, 2, and 3 as shown in the figure. Now, we are analyzing these three molecules by simple trigonometry. Join 1 to 2, 2 to 3, and 3 to 1, resulting in a triangle. As all the dimensions are very small, horizontal distance is taken as dx, vertical distance as dy. An angle, d theta, is considered as shown in the figure. We know, tan theta is equals to opposite side by adjacent side. Here, tan d theta is equals to dx by dy. We have, for small angles, tan theta is equals to theta. So, from this we get, d theta is equals to dx by dy. This is our equation 1. Velocity is defined as the ratio of distance traveled or displacement, by time. Horizontal velocity in x direction is taken as du. So, velocity du is equals to distance dx by time dt. From this, distance dx can be written as velocity du times time dt. Substituting this value in equation 1, we get d theta is equals to du times dt by dy. By rearranging the terms, we get d theta by dt is equals to du by dy. This is our equation 2. This is the equation for rate of change of angular deformation. Newton's law of viscosity. The shear stress acting at a distance of dy from the surface of a flowing fluid is directly proportional to rate of change of angular deformation. This is an important fluid law. That is, shear stress is directly proportional to rate of change of angular deformation. Tau is directly proportional to d theta by dt. By removing proportionality sign and introducing a constant, we get shear stress, tau is equals to mu times d theta by dt. From equation 2, substituting d theta by dt is equals to du by dy. We get shear stress, tau is equals to mu times du by dy. This is the final equation from Newton's law of viscosity, where mu equals coefficient of viscosity or dynamic viscosity. Units of dynamic viscosity are Newton second per meter square, or kilograms per meter second. Property 6. Surface tension. It is denoted with symbol, sigma. Surface tension is the attractive force found in liquids, which is responsible for pulling surface molecules in the rest of the liquid. Further, it minimizes the surface area. The attractive forces we are talking about here are because of electrostatic forces. Surface tension is equals surface force divided by length of force acting. Sigma is equals to force, F, by length, d. Different conditions for surface tension are 1. In a soap bubble, 2. In a water droplet, and 3. In a jet of a fluid. From the concept of surface tension, internal pressure for above cases are found. The formula for internal pressure, delta P, in a soap bubble, is given as 4 times sigma by r, where sigma is surface tension and r is radius. The formula for internal pressure, delta P, in a water droplet, is given as 2 times sigma by r, where sigma is surface tension and r is radius. The formula for internal pressure, delta P, in a fluid jet, is given as sigma by r, where sigma is surface tension and r is radius. Property 7. Capillarity. Capillary height is denoted with small h. When a small diameter tube is inserted in the fluid reservoir, there will be either rise or fall in the water level depending on the type of fluid. This phenomenon of either rise or fall in the water level is called capillarity. If there is rise in the water level, then it is called capillary rise, and if there is fall in the water level, then it is called capillary depression. Both capillary rise and capillary depression are combinedly called capillary height, h. If the density of fluid is less, then we see rise in the water level, and if the density of fluid is more, then we see fall in the water level. Capillary height is calculated by the formulae 2 sigma cos theta by rho gr, where sigma is surface tension of the fluid, rho is equals to density of fluid, g is acceleration due to gravity, r is radius of tube inserted, and theta is angle of contact of fluid with capillary tube. Theta is taken as 0 degrees for water, and 135 degrees for mercury. Property 8. Pressure. Pressure is denoted with small p. It is defined as external force acting per unit cross-sectional area. Pressure, P, is equals to external force acting, F, per unit cross-sectional area, A. P is equals to F by A. We know, force is measured in newtons and area in millimeters square. Units of pressure are newtons per millimeters square. Other units of pressure are A. Pascals, 1 Pascal is equals to 1 Newton per meters square. B. Atmospheres, 1 atmosphere is equals to 101,325 pascals. C. Bar, 1 bar is equals to 10 to the power of 5 pascals. D. Kilogram force per centimeter square. 1 kilogram force per centimeter square is equals to 0.981 into 10 to the power of 5 Newton per meters square. Types of pressure. Pressure is characterized into 4 types. They are 1. Atmospheric pressure. 2. Absolute pressure. 3. Gauge pressure. 4. Vacuum pressure. Atmospheric pressure is the pressure exerted by environmental mass on any matter. Absolute pressure is the net value of pressure exerted on a system measured with respect to 0 pressure level. Gauge pressure is the pressure above the atmospheric pressure. And vacuum pressure is the pressure below atmospheric pressure. If the pressure measured is above atmospheric pressure value, then the value above atmospheric pressure is taken as gauge pressure. If the pressure measured is below atmospheric pressure value, then the value below atmospheric pressure is taken as vacuum pressure. Absolute pressure at any point is the pressure measured from 0 point. This graph shows different types of pressures. Absolute pressure is equals to atmospheric pressure plus gauge pressure as shown in point 2. Or absolute pressure is equals to atmospheric pressure minus vacuum pressure as shown in point 3. This slide deals with hydrostatic pressure acting on a fluid. This concept is given by Pascal, hence called Pascal's law. Pascal's law states that a pressure change at any point in a confined incompressible fluid is transmitted throughout the fluid, such that the same change occurs everywhere. For this, a fluid molecule in static fluid is considered, at a depth of h from the surface, as shown in the figure. Now, pressure acting from the top and from bottom on the molecule, for the molecule to be in the equilibrium are considered, along with its weight, is acting in vertically downward direction. All the above parameters are shown here. We know, pressure is equals to force by area. From this force can be written as pressure times area. Now by equating forces acting on the molecule and integrating them, we get pressure P, is equals to rho, g, h. Where, rho is the density, g is the acceleration due to gravity, and h is the height of the fluid above considered point. Pressure measuring devices. Pressure measuring devices are differentiated as conventional devices and modern devices. Conventional devices include barometer, piezometer and U-tube manometer. Modern devices include Bowden's gauge, strain gauge transducer, and piezoelectric transducer. All the conventional devices use the concept of hydrostatic law given by Pascal. First, barometer. This is a local pressure measuring device, made by Torricelli. Pressure here is measures in torr. 1 torr is equals to 1 millimeter of mercury, which is equals to 133.33 pascals. Second, piezometer. This instrument is used for measurement of low gauge pressures of liquids only. Setup of this device is shown here. Piezometer is generally provided at water tanks, to know the water level inside the tank. Finally, manometer. U-tube manometers are widely used devices to measure pressure in a flow or pressure difference between flows. Manometer is a small diameter tube with high-density monometric liquid in it. Generally, mercury is taken as monometric liquid, as the density of mercury is high. This device also uses the concept of hydrostatic law of fluids given by Pascal. Manometers are of two types: simple U-tube manometer and differential U-tube manometer. Simple U-tube manometer is used to find pressure at a point in a flow. A simple setup of simple U-tube manometer is shown here. Differential U-tube manometer used to find pressure difference between 2 points. Its setup is shown here. All the modern devices to find pressure are directly calibrated to give pressure value directly. Thanks for watching the video. Please like the video and subscribe to my channel if you like the video.